This is the Cambrian Period. Right now, the Earth is pretty much made out of water. All the continents are combined as one to make a supercontinent. These are two significant life forms that adapted to survive in this kind of climate, the Anomalomachirus and the Pikaia. The Anomalomachirus adaptation is his hard exoskeleton. It's like metal. When two of them would attack each other, it sounded like metal colliding. The Pikaia, well, he didn't really have that many adaptations, but he was slow and he had some plated skin, I guess you could say. And he was slow and he wasn't fast like other fish during this period. This is the early Devonian period. The period had two major supercontinents. One was called Gondwana, and the other was called Euramerica. This period was pretty much still water, but the first plants started. They had no roots and leaves like normal plants. Two new creatures that have adaptations now are called the U.S. Thermoopterans and the Dunkleosteus. The Dunkleosteus was the first and biggest fish with protective armor, and the other ones were the first animals to walk on land. Notice they still have fins, so there's still more adaptations that can happen, and I'm pretty sure they can't breathe the air. They have to go in every so often. Later on, a major collision was set in motion that would bring the two together to form the single world continent, Pangaea, in the Permian. This is the early Carboniferous period. It goes from 350 to 300 million years ago. As you can see, the continents are slowly drifting apart. Like Euramerica and Gondwana used to be together, now they're splitting apart again. Two significant life forms that lived back then were the Varanops and the Predaherps. Okay? These two were the first land animals with, I guess you could say, feet. Like, back in the Devonian period, these creatures had fins. Now they adapted, now they have hands to walk with. Also, in this time period, the first real trees and plants, I guess you call them ferns, with actual leaves came, and there was swamp forests. It actually was starting to look like planet Earth we see today. But not for too long, because soon the Earth became cooler and drier. And continuously it kept dropping 10 degrees Celsius. Also, another fact is these two animals were the first reptiles to ever step on Earth. This is the Permian Period. As you can see, all the continents are sort of heading towards the east, but some of them are reconnecting. In this time frame, there are mass extinctions, leading the animals' population to decrease. But only the animals that have the right adaptation can survive this climate change. The two significant life forms that I chose from this time period are Dimetrodon and Lystrosaurus. First, we're going to talk about Dimetrodon. Dimetrodon is mistaken for a dinosaur more often than any other prehistoric reptile, but the fact is that this creature lived tens of millions of years before the first dinosaurs had even evolved. Now we're going to talk about Lystrosaurus. Lystrosauruses are flat-faced, with a beak and two teeth that resemble tusks. Lystrosauruses were synapsids, animals that arose in the Permian and eventually gave rise to mammals. This is the Triassic Period. As you can see, the continents are slowly shifting into place. Some of them are still attached like Eurasia, Europe, and Asia, but they will soon come unattached to form our continents we see today. Also in the Triassic Period, the first mammals and the first dinosaurs came to be. I am going to be talking about two of the newest dinosaurs in this period, the Celosaurus and the Massospondylus. First, we're going to be talking about the Massospondylus. The Massospondylus were one of the strangest dinosaurs. They were herbivores. Massospondylus was known to have lived in North America and South Africa during the late Triassic period to the early Jurassic period. It is said to be a strange dinosaur because of the shape of its limbs and the body. Masopondylus had a small head on the end of a long and flexible neck. It has 2 hands and 2 legs. Each of its hands had thumbs outfitted with a large claw and 4 other fingers. The arms of the dinosaur were known to be used for grasping and for walking. The length of the Masopondylus, was about 13 feet long, and its height was about 6 feet tall at the hips. An adult Masopondylus would weigh around 1.5 tons. The long neck of the Masopondylus would have helped it to reach the tall branches of trees easily like a giraffe. The legs of this dinosaur are slightly longer than its arms. The dinosaur also had a long tail. Masopondylus were known to be the fastest runners as compared to other dinosaurs, and this dinosaur is known to have had a lower intelligence as compared to other species of dinosaurs. Now we're going to be talking about the Celosaurus. The Celosaurus was one of the largest dinosaurs. The Celosaurus is a genus of prosauropod dinosaur that lived in Triassic Europe. It was about 23 feet long, 7 feet tall, and weighed 2,000 pounds. It had a thumb claw that may have been used for defense and to reach for food. Even as the assembly of Pangea was completed, it began to rift apart. By the end of the Triassic, rifting in the center of Pangea had begun. North America began to pull away from Europe and Africa, and blocks of crust sank to create rift valleys. During the late Triassic and early Jurassic, these valleys were associated with the initial formation of the Atlantic Ocean. Early Triassic climate was quite similar to that at the end of the Permian. Much of Pangea was warm and dry, and the interior of this supercontinent was particularly arid, or with no rain, or some rain, but not a lot. This is a Triassic period. As you can see in the picture, the continents are almost to where they normally are in everyday life today. As you can see, South America and Africa are still attached together. They need to move apart. And it's a central Atlantic Ocean on the map. That means that the Atlantic Ocean has now been created and is now in our planet. In this period, birds came to life, and more different types of dinosaurs started appearing. The 2 significant life forms that I took from this era are Dimorphodon and Archaeopteryx, okay? Now, they are both flying, and this is a new adaptation for life. I am going to talk about Archaeopteryx first. The Archaeopteryx, known as the first bird, is the most primitive bird to ever existed. The creature lived during the late Jurassic period in a southern region of present-day Germany, at a time when Europe was nothing but an archipelago of islands. It is said that the prehistoric animal was only the size of the common magpie we all know today, which is about 1.6 feet in length. However, while the Archaeopteryx was petite, or small, he was full of feathers and seemed harmless. The creature actually had extremely broad wings and razor-sharp teeth. It also had claws located on the fingers and the second toes. The toe claws were hyper-extensible into something referred to as the killing claw. Now we're going to talk about the Dimorphodon. The Dimorphodon was a pterosaur of medium size, said to live during the early Jurassic period. The creature had 2 different types of teeth in its jaws, which is rarely heard of when examining reptiles. The Dimorphodon stood at about 3.3 feet tall, with a small neck but large head, and had a wingspan of 4.6 feet. It had a tail that included 33 vertebrae, which may or may not have been used as a balancing mechanism when walking, but was definitely used during flight. Pangaea, which had begun forming in the Devonian period and lasted through the Triassic, finally began to split apart in the late Triassic. By the middle and late Jurassic, enough plate movement had occurred to separate South America from South Africa. Laurasia, which is North America and Eurasia, also moved away from Africa and South America, helping to create the Atlantic Ocean and the Gulf of Mexico. Volcanic activity was common along these rifting continental margins. At the same time, Eurasia, Europe, and Asia moved to the south and started to close off the Tethys Ocean. Sea level gradually rose during the Jurassic, creating epic continental seaways in North America and Europe. The end result was a world with many more separate land masses and a great deal more coastline than the world of the Triassic. Now I'm going to talk about the Jurassic climate. Much of the Jurassic world was warm and moist, with a greenhouse-like climate. Coal deposits formed under forests in Australia and Antarctica. Although some arid regions remained, much of the rest of Pangaea was lush and green. Northern Laurasian and southern Gondwanan biotas were still distinct in many ways, but by the Jurassic, faunas had acquired a more intercontinental character. Some animals and plants were now found nearly worldwide instead of being restricted to particular regions. In this era, the Cretaceous era, dinosaurs went extinct, plants started growing, real plants, and primates came to life. I will be talking about two significant life forms that lived during this period: the Bonapartenicus ultimus and the Ornithorynco. The Bonapartenicus ultimus went extinct shortly after a little while in the Cretaceous period. So that is why we are going to be talking about him first. The Bonapartenicus ultimus is a genus of alverosaurid theropod dinosaurs known from the late Cretaceous period of northwestern Patagonia, Argentina. Now we are going to be talking about the Ornithorynco. The Ornithorynco was a species of prehistoric monotreme, egg-laying mammal, from the nearly Cretaceous period, meaning that it lived with dinosaurs, giant crocodiles, and other early animals. This prehistoric mammal is known only from a single jaw that was found at Lightning Ride in Australia. It, like most monotremes, was fairly small, as it only grew up to 50 centimeters long. However, it was large by Mesozoic standards, as most mammals only grow 1 to 2 centimeters long. It probably lived a similar lifestyle to the modern platypus. The climate of the Cretaceous period was hot. It was so hot that there was no polar ice. During this time period, Pangaea continued to break apart into supercontinents, like Laurasia and Gondwana. As the continents continued to move, the differences in the plants and animals that existed in the northern and southern continents began to increase. This is the Tethys period. As you can see, the continents are almost positioned exactly as they are today. The Tethys period brought new mammals and a lot more different kinds. I picked out two significant life forms that are pretty much the same. They're kind of like brothers, I guess you could say, but they don't look the same. Their names are Indricotherium and Brontotherium. I am going to be talking about them at the same time. The Indricotherium was the largest land mammal ever, weighing 4 times that of a modern elephant and twice that of the largest known mammoth. The Brontotherium was distantly related to the rhinoceros and had a forked horn on its snout. Earlier hominids, human ancestors, appeared in this time period too. Other mammals that appeared for the first time were pigs, cats, deer, rhinos, and tapirs. Plants thrived all over the earth during this time period. Many of the plants that grew in this time period were similar to what we see today. There were dense forests, grassland, and open woodlands. It was so warm and moist that palm trees grew as far as Greenland. In the Tertiary period, there was lots of grass for the animals to feed on, flowering plants, and dense forest. This covered most of the earth. At the end of the time period, the cooling climate caused the polar caps to freeze and be covered with large glaciers. When this happened, the sea levels dropped and land bridges appeared between Asia and North America, between Great Britain and Europe, and between Southeast Asia and Borneo. This was significant because it allowed the migration of plants and animals to new areas on Earth. The rock cycle is all a part of the dynamic Earth we live on. It demonstrates how the three major rock types are all intertwined with one another. These three are igneous, metamorphic, and sedimentary rock. Molten material, known as magma, solidifies to become an igneous rock. The rock will sometimes undergoes process known as weathering. This unconsolidated material becomes lithified or cemented. It becomes a sedimentary rock, or after solidification it may be exposed to extreme heat and pressure without melting, and metamorphism occurs, resulting in a metamorphic rock. In sedimentary rocks, as the heat and pressure builds from layer upon layer being deposited, metamorphism may occur. Again, resultant rock is a metamorphic rock. Sedimentary may be directly melted, resulting in an igneous rock. In metamorphic rock, it in turn can erode to lithify and become sedimentary or melt to become igneous. So I guess you can say that all three rock types depend upon each other. The formation of soil happens over a very long period of time. It can take 1,000 years or more. Soil is formed from the weathering of rocks and minerals. The surface rocks break down into smaller pieces through a process of weathering and is then mixed with moss and organic matter. Over time, this creates a thin layer of soil. Plants help the development of the soil. They help it by having them attract animals. And when the animals die, their bodies decay. And that means that that decaying matter makes the soil thick and rich. This continues until the soil is fully formed. The soil then supports many different plants. This is what planet Earth looks like with all the continents shaped in the right position. This is when humans came into the picture, took over Earth. This is the evolution of humans. The Earth has adapted, and so has animals, to create us. This time period is called Quaternary. That is my presentation of the Earth from the past 500 million years.